Did you know that Malaysia generates approximately 16,688 tons of food waste every single day? When this waste is disposed of in landfills, it decomposes and releases greenhouse gases, contributing to 8 to 10% of global emissions worldwide. Instead of treating food waste as a problem, it can be transformed into a valuable energy resource. One promising solution is the production of biohydrogen. This process uses a specialized anaerobic microorganism called Clostridium Butyricum, which converts food waste into hydrogen gas through a process known as dark fermentation, meaning it occurs without the need for light. However, to make this process efficient at an industrial scale, engineers must prevent the microbes from being washed out of the reactor. This is achieved through microbial immobilization. One widely used method is entrapment immobilization, where Clostridium butyricum cells are physically trapped inside porous calcium alginate gel beads. These beads allow nutrients to diffuse in and fermentation products, such as hydrogen and butyric acid, to diffuse out, while keeping the cells inside the system. Immobilization also protects the microbes from high acidity, which can otherwise inhibit their activity. As a result, it increases cell density, improves process stability, and enhances hydrogen productive overall. This engineering approach is technically feasible, cost-effective, and supports a circular economy, reducing landfill waste while producing clean energy from materials we once threw away.
Well, how do you measure an idea's trip from the lab to the real world? There's a scale for that. It's called the Technology Readiness Level, or TRL. You can think of it like a ladder for new tech. So, this tech traps special bacteria in tiny gel beads. Their job? Making hydrogen from food waste. And this idea is already on its way. It's past the first 3 steps, so the basic science works. Right now, it's sitting at Technology Readiness Level 4. So, what exactly does that mean for us? TRL 4 means it works, but in a controlled lab setting. So we're officially past the theory stage. We know the process works on a small scale. The beads protect the bacteria, but it's not industry ready yet. Okay, so the next leap is a big one. We're talking about going from the lab to industrial conditions. So what's really holding it back from hitting that next level? What are the roadblocks here? Well, 2 big things: getting nutrients into the beads and making sure the beads themselves don't break apart. But don't worry, researchers are on it. They're looking at ways to strengthen the beads and boost efficiency.
For our project to really work, we first had to see what the public actually thinks about it. Our specific plan is making biohydrogen from food waste, using this calcium alginate entrapped bacteria. But, are people even on board with this? We really needed to find out. So first up, let's see who we talked to. We got responses from 50 different people. Turns out our audience is mostly young, between 18 and 25, and almost all have degrees. And here's the key. A lot of them have a tech background, so they get the basics. We kicked things off by asking what benefits people actually saw in our project. Clean energy and cutting emissions were the big winners. That's what people really valued. Okay, but what are the biggest worries? Let's jump into the health and safety concerns. Bad smells and potential contamination are the top 2 fears by a pretty clear margin. And when you talk about safety, gas leaks and fire hazards are definitely top of mind. Get this. Only 14% of people we asked think this whole process isn't dangerous. So all these concerns lead to one big question. What do people expect from us as engineers? And the public is pretty clear on this. They're demanding action from everyone involved. Basically, they want regular checks, total honesty on safety, and some strict rules in place. So this data gives us a really clear path forward for getting public buy-in. But that acceptance is conditional. A huge 70% need to see proof in government approval. So the main takeaway here, we have to earn our social license with proof and transparency. This survey gives us a real data-driven plan. Now we just need to get to work. In cutting-edge research, we get excited about the science, the big breakthroughs.
But the really tough questions, they're often not about the tech at all. So this exact question was put to 2 experts in the field.
So let's really pull this question apart and see what's inside. First up, what's the actual technology we're even talking about here? All right, so with something this new, what are the rules? What do researchers have to follow? Which brings up the next point. Whose job is it to make sure everyone follows those rules?
Dari segi peraturan yang kita kena ada, kita kena ikut daripada pihak-pihak tertentu yang diorang dah sediakan, seperti macam menjaga environment dari segi aspek orang pula, kita lebih pada kena jaga keselamatan supaya tak ada kecederaan yang berlaku dalam pekerjaan tu.
Okay, so when working with new and emerging technologies, regulatory awareness is really important, even in a research or lab setting. Although many biohydrogen systems are still in the development stage, they already involve biological materials, waste handling, and flammable gases. All of these are covered by safety and environmental regulation. So because of this, people working in lab need to make sure their work follows biosafety guidelines, environmental rules, and chemical safety standards. There is also an ethical side to this. Lab professionals are responsible for doing risk assessment, keeping proper safety records, and reporting incidents or near misses. It is not just about following the rules, it is also about being careful and aware, especially when working with technologies that could be scaled up in the future. By practicing good lab ethics, we help to protect not only ourselves but also the community and environment.
Malaysia has a massive food waste problem. But what if we could turn that waste into clean energy?
It all starts with this idea of a circular economy, a really smart, sustainable way to handle waste. The promise is huge, turning our daily food scraps into a clean source of biohydrogen energy.
Okay, so it sounds great, but how far along is this technology from being a reality?
Well, right now it's at what's called Technology Readiness Level 4, or TRL4 for short. That just means it's proven to work perfectly in the lab, but it's not ready for prime time yet.
To scale it up, engineers have to solve a few key issues, like making parts more durable and efficient.
But here's the thing. Even with perfect tech, that's not the final hurdle. Not even close.
The biggest challenge of all, moving from the lab to our communities, is all about public trust.
And building that trust is absolutely crucial. It really comes down to a clear, three-step plan.
The goal here is simple, to make sure this whole process is safe for everyone and the environment.
So when you boil it all down, technology is only half the story. The real question is, can trust complete the puzzle?